Okay, now this is chapter 10.4, and we'll explore the relationship between exponential equations and logarithms. And we've seen previously that some functions have an inverse function, which means that if you have a function f where x is the argument and then y is the function value, you could say that, okay, for every f of x you have a y. Now, if you had a function g where for every y you had an x value, then in that case g would be the inverse function to f. And we'll see how that works in practice with an exponential function and a logarithmic function. And let's call them f and g. So f of x is 10 to the power of x. And g of x is the logarithm of x. So if we wanted to draw these in GeoGebra, the first one is called f of x. What was it? 10 to the power of x. So 10 to the power of x. All right, so there we have it. The other one is g of x equals log x, like this. And what you can notice then is, if we just adjust these so that they are perfect squares, more or less, yeah, like that. You can see that these functions mirror each other. So you could draw a straight line between them here, and that would be, I could do that like this. Yeah. So the line x mirrors these two functions. And if we examine this, if you look at the second function, when x is 1, the function value is 0. For the other one, when x is 0, the function value is 1. So it's the opposite. Yeah? We could try that with f of 2. F of 2, you get a function value of 100. If you take g of 100, you get 2. So that's what an inverse function does. So you get the mirror image of the other function. So in a way, it's the same function that has been applied to the other axis. So this function here, when it's turned into its inverse function, this becomes the first axis in a way, and this becomes the second axis. So we'll continue exploring logarithms and see how we can solve some logarithmic equations.